Hello, thank you for joining to my presentations. I will speak about the IoT Hub. The key point of this presentation is to see what are the features that IoT Hub service allow us to control mobile devices or any other IoT devices. I'm Stefan Janev. I am a developer for more than 11 years. Previously, I was embedded developer, so that was my passion for IoT devices. And currently, the last 4 years, I'm an Android developer in Melon. What is actually the Azure IoT Hub? It is a central message hub that control the devices in a secure way and establish this communication between the IoT devices and the IoT application, which is hosted on the cloud. In this service, there is a supporting for creating those devices, establish that connection with them, and even if something has been failed, to give the information about it. Where we can use it, the IoT Hub. Everywhere we have mobile devices, wearable devices, even the machines in the kitchens nowadays are smart, so even there they could be written some software to control them through cloud and with our mobile devices to have information about their state. I know that some of those features are already known by users because you're using different services for communication. But from IoT Hub perspective, we have some of them which are quite new, and I will speak more about them. So the first one is telemetry, which means it's updating the cloud with new information about some temperature on the devices, if something, some event happened, some alarm, some trigger happened, and that will tell us. Next one is the device properties, which in Azure IoT Hub it's called as a twins, because it's hosted on both sides, on device and cloud. And device commands can be used for any interaction that we want to be done, and we expected some results from it. Inside the IoT Hub service is added also uploading of files, even that is not a common case for services that want to communicate something. But because on Microsoft the services, it is already there, they just connect the APIs and allow us to do that. And the last one is device provisioning. That is quite important if we want to provision some devices that were not previously connected, or we want to update them later with proper versions, or even some configuration like allowing another feature. So this is a new service that most of the time it's using the device twin for performing the stuff. Since the device twin is quite new, I would speak more about it. So the first side is device, and the second one is the cloud part. We have desired properties which can be set by the cloud side from the backend application that is written there. And the reported properties are actually sent from the device. This you can see as having the same configuration in both sides. So when the device connects to the cloud, it will receive the last information that were stored, and it will have as a copy of that information. It is just a JSON file with objects that later could be changed or set something on device side. the tags that only on the cloud side as a part of this device twin. It reserves to set some jobs on the IoT part to execute something. It could be sending a messages, bunch of messages to all devices that are with the same tag, or even update the application on the device if they are having the appropriate tag. Now I will go again about the features that could have as a communication between the devices. So the first, and from Android perspective and iOS, we previously were using Firebase or push messages. So that is the same feature. Sending message from the device to cloud is options when we want something to get back to the cloud. And for that, previously we tried to use some API calls that now are not needed anymore because we have a two-way communication. Retrieving and updating the device twin properties, receiving some direct method from the cloud, and initiating the file uploads from the device. For all the previous communication that I have mentioned, we can use some of those protocols that are stated here. The MQTT and AMQP are most common that are used. And the last one, HTTPS, is used only in case the devices that we run the IoT application, the embedded or Android application, it could not support the MQTT or AMQP. That is the case on iPhones because they don't like to have MQTT or AMQP. They mentioned that it is because battery consumption, but MQTT actually is not take that much battery, and that is why it is using on embedded devices because it's lightweight. And for the iPhones, we must use HTTPS, but we must pull the messages because we don't have two-side communication. Now we will speak about the communication from the device to the cloud. So the first one is telemetry, which could be send some alerts or events. The payload, the maximal size is 256 kilobytes per message, and the most important is that this could be done with high frequency because the things could be changed very often on the device. Even we can send sometimes logs of the application that are running, and we will inform the cloud that something happened bad. The frequency depends on the subscription on the Azure services. So based on what type of subscription we have, it could get from 100 to 6,000 messages per second, and all protocols are available for this feature. For the reported properties, there we put some state configuration or information about the software update if needed. The size is 32 kilobytes, and the frequency is medium, so we don't need to use all the time for sending some new information. It's just some basic configuration that usually should be done on the beginning. And the requirement for this is the MQTT and AMQP protocols. About the file upload, it's just Azure blob storage uploading file, and the frequency is 100 files per minute, and usually it always uses the HTTPS protocol. Now we'll go from the other side, from the cloud, to send some messages to the device. This is the push messages we always talking about, and the size could be 64 kilobytes with low frequency with 100 per minute, and it's supported on all devices, and as I mentioned, just 8 HTTPS must be used by pushing. About the device twin, this is the configuration that cloud should set up. It could be some state of the application, how should behave during the time, and the size is 32 kilobytes per property with medium frequency and using the MQTT MQP. Direct method, that is quite important for using the provisioning also. It could be used because we must to initiate something and we need to get some feedback that if that is started or it failed immediately, and the timeout for waiting we could configure. I will show you later on the demo, but it is configurable. It could be more than 30 seconds. It's not something that must be done immediately, but yeah, we must return some status. The payload is 138 kilobytes and could be used with high frequency. From every services and every features we mentioned here, they later on the cloud side could be connected with other Microsoft service like message routing or event grid. So later you can use to do everything you want on the backend side with those data you have. Available SDKs. So most of the most languages that are supported is on both sides, on the SDK and on the service and the device. Only the C and C++ are supported only on device because we don't write a backend side application with C++. And the most important are .NET, Java, Node.js or JavaScript on the other side, and Python. This is the connection flow and that we must perform on the beginning. I would not use any code to present here because it's pretty much the same, but the naming of the APIs are quite different. One of the most important information that we must to have before establish the connection is a connection string. The connection string we must to get it from the server before starting the connection. It usually takes by login to the server with email or password. Then later the server will return you the connection string. After you have the connection string, you can create a device client, which also needs the protocol which would be used for the connection and some client options. After connection, device client is done with initialization, we should register a connection status callback. It will tell us if the device is connected, disconnected, or it is trying to reconnect if connection failed before. Later, we set the timeouts and retry policy. Timeouts, it's on every operation we are using. It is having the same timeout. That, from my opinion, is very bad implementation, but that is how it's done. There is one parameter that exists on the C++ library that is keep alive parameter that will tell how often to ping cloud to check if the connection is established. Sometimes that is very important for real-time operations when we want to have very real-time communication between the devices and if something happened, immediately to inform the cloud. After having everything configured, we just open the connection. Once the connection is open, we can just subscribe only to the options we wanted to use, like messages, device method, or device twins. What will help us for developing the applications, it's always the tools that comes with the from the IoT Hub. So one of the most important that is using is Azure IoT Explorer. It have options to create the device, manage device, everything you want on that. And one new feature is plug and play, where you need to write a model. Model is actually the objects that would be used for the communication. You will define them in the new digital twin definition language. And later on, it will have a better UI on the Explorer, IoT Hub Explorer. You will have a better UI to see the data there, not just to get raw data in JSON. And the last one, when we use the uploading of the files, we can manage that with Storage Explorer to set up blob and even check what is uploaded there. Yeah, now I will switch to the demo. Here on the right side, I have one demo Android application, and on the left side is IoT Explorer. From the IoT Explorer, we have listed all IoT hubs that for which we have a connection string. So we take the owner connection string to create this one. And for the IoT Hub plugin, we just put where is the path to the models that we will use later. From the IoT Hub instance, we have here registered only one device. If we want, we can just create another one, put the name of the device, use which authentication method we will use. It's usually the symmetric keys, and connect with this device. Because I have a device configuration, device twin configuration, I will use the already created one. For it, we have a connection string. This is the primary connection string. Is actually the this one is the connection string that we will use in the Android application. So we must have that previously taken. Okay, I will just describe what are the parameters here. So we have the device twin. Here is listed the desired properties, which is set from the cloud side. It could be some firmware version that are available, the telemetry config, like uploading the logs in which order to be called them. And also at the bottom side, we have the reported one, which the device will tell us maybe the connection string is broke. Okay. And for the direct methods, here we have options to write the name of the direct method that need to be sent and the payload. Here is the connection timeout that could be set up for different time, and those are the push messages. I will check if it's arrived. No. About the plug and play, here I have the default component, which is the model ID. This model ID must be set up on the Android side project, and I will try to fix the application. And the default components we must to choose if we want to use that DTDL language models that we have written. So here down is the script, and in the options we have the properties that are defined. Here we need to just to run again. On the properties that would be set from the cloud side, we have here the telemetry config, the logs and log frequency. We just update the device when it's connected. And the last thing are the commands. The command you can have, if it's Boolean, you can have true false commands, or even some string. And for the telemetry, it will recognize the events that are shown in the models. Actually, we need to use in the model events that will present us in a better way. Yeah, I have a problem with the device. So actually happened the issue that is common happen on this IoT Hub function. So maybe this is a good demo. For MQTT, it's very important only one device to connect with the same connection string. If several devices connected with the same connection string, you will get some of these errors, like a not authorized, or even some more strange errors. So, that is because MQTT doesn't supporting multiple connection. From the other side, IM2P it support, but it takes more memory for doing that. I will again just try to take the connection string. Maybe it's changed somehow. If not, I will stop the demo. In the meanwhile, if anyone have question, maybe it's good to have the time.
Okay. So, do we have any questions? We might have some t-shirts to sweeten the deal, by the way, so you might want to consider. Please do. Microphone.
Okay, try.
Okay, thank you, Mr. Chairman. I'm just like, just to stop the speculation, it's not because I see that you're using the emulator, sometimes works, sometimes doesn't work. That's understandable, and that's one of the big problems. Meet the faces behind the code. It's always like this, a lot of struggling. I'm asking, have you tried to develop some apps that can, allow you to use blockchain technologies, like doing smart contracts? We saw the previous talk about JavaScript, that you mine Solidity and that kind of stuff, or even the something related to the Bitcoin script, etc. So I'm just like curious.
Yeah.
It's a question out of nowhere, but maybe as a possibility to think about it. Thank you.
Yeah. So I haven't using anything like that, but yeah, it could take as options to use, but no, I was using only on wearable devices, Android devices, on the Tizen devices, which is written in the C application, the background application, and of Wear OS, that is Android actually, but it's using the same APIs. The good thing for Android, other options that you already have a prebuild for the libraries. For C++, you must build by your own because it's specific per devices. So if you take with C++, just have 2 or 3 days to build the library, so it takes some time. But yeah, with the blockchain, we didn't have any projects like that to work with.
Any other questions?
Just a quick question. Does the device SDK support any type of recovery if the network connection goes offline, in terms of keeping the data and sending all of it in one go afterwards, just to not lose what happens?
So it's quite different depends on the operating system you were working. Because on the C part, when you lost connection and you're having a small keep alive timeout, it will inform you that you're disconnected. But on Android, that is the bad side of that timeout, because usually we want to have not pinging that too much often the server, so we have like a 5 or 15 minutes. And in that case, the library, the IoT Hub library, would not tell you that you are disconnected. And you must to have another service that will ping Google or whatever, and to have more better connection status information, because otherwise you will lost. And this issue that I have right now is because I need to restart the emulator. It keep in background the previous MQTT connection, and on the Java side, it always must be closed in a good way. Otherwise, it will stuck like this. But on C++ side, you must to open only once in the life of the starting of the device, and that is you don't have to kill, because if you kill and try to create another client device, you will stuck again like this. So that is one of the biggest problems that we had during the development.
Okay, great. So please, a round of applause for Stefan.
Thank you.